Good morning. So we'll see ഇപ്പോൾ നമ്മൾ deadlock avoidance പറഞ്ഞ എന്താ നോക്കാം. So the deadlock avoidance it is coming under the second condition. So deadlock ൽ മൂന്ന് category ഉണ്ട്. Deadlock avoidance, deadlock prevention, deadlock ignorance and recovery. So ഇതിൽ we'll see deadlock avoidance. It is very important thing. ഈ deadlock avoidance if you want to tell something we have to go for safe state. ഇതിൽ very important thing in deadlock avoidance we need to find out there is no circular wait condition വന്നിട്ടില്ല നമ്മൾ ഉറപ്പാക്കണം. So once that come, how we are going to find out that അത് വെച്ചിട്ടാണ് നമ്മൾ we are going to come with the safe state sequence. So ഇതില് the safe state sequence is something like if there will be n number of process will be the current availability വന്ന request നമ്മൾ check ചെയ്ത് if the thing is okay we'll give, if not come it will be not give. So ഈ bankers algorithm the best example, for example deadlock avoidance we'll try to use the bankers algorithm. ബാങ്ക് പറഞ്ഞ എന്താ, ഇറ്റ്സ് എ റിയൽ ടൈം അപ്ലിക്കേഷൻ. സോ റിയൽ ടൈം പ്ലേസിൽ നമ്മളൊരു ലോൺ ചോദിക്കുന്നുണ്ടെങ്കിൽ ഫസ്റ്റ് ദ ബാങ്ക് മാനേജർ വിൽ ചെക്ക് വെദർ ദേ ഹാവ് ദ അവൈലബിൾ അമൗണ്ട് ഉണ്ടോ ഇല്ലയോ നോക്കും. ദെൻ they'll ask if the amount is available നമ്മുടെ അടുത്ത് all the procedure they'll ask you to stop, then അവർ പൈസ തരും. സോ they'll check based on എത്ര ആൾക്കാർ കസ്റ്റമർ അല്ലാതെ എത്ര ആൾക്കാർ ഡെപ്പോസിറ്റ് ചെയ്തിട്ടുണ്ട്, ഇങ്ങനത്തെ ബേസ്ഡ് ആണ് ലോൺ കൊടുക്കുക. സോ സെയിം ടെക്നിക്സ് they followed it in the real time. So ഇവിടെ safe state sequence പറയുന്നതും അതാണ്. So whether the bank it isn't safe or not, we can find out with that particular thing. So ഇവിടെ safe state sequence if the safe state is not, if the particular thing is not in safe state, it shows that there is a deadlock. If it is in particular thing, probably e diagram നോക്കുക. Safe state if it is safe there will be no deadlock. If this state is not safe, it shows there might be lead to a deadlock condition. നമ്മൾ അത് എങ്ങനെയാണെന്ന് നോക്കാം. So in this particular thing, the deadlock avoidance algorithm basically divided into two categories. One is resource allocation graph. So resource allocation graph every use for a single instance of each resources, and bankers algorithm will be using for multiple instances of resources. So we'll see the particular thing. Resource allocation graph already number down. There are two things. One is a climb edge or request edge or assignment edge. Climb edge പറഞ്ഞ സ്ഥലത്തില് PI it will be requesting for the resources. For example, in this case PI it is requesting for RJ, so we are telling it is a climb edge or request edge. Whereas in other one assignment edge, so process വന്നിട്ട് ഒരു already it will be assigned something, a resource will be assigned to something else. So ഇതാണ് resource allocation graph നമ്മൾ നോക്കാൻ പോകുന്നത്. So this is the particular thing. If you take there are two processes there, two resources are available. So R1 it is hold P1 it is hold resource 1. ഇവിടെ P2 it is requesting for R1. So ഇങ്ങനത്തെ looping if it comes it will lead to a deadlock. So അത് വരേണ്ട നമ്മൾ നോക്കണം. So ഈ bankers algorithm like I already told ഒരു real time banking application വെച്ചിട്ടാണ് ഈ algorithm കണ്ടുപിടിച്ചത്. So this was developed by Deckers. So നമ്മൾ ഇത് എങ്ങനെയാണ് വർക്ക് ചെയ്യുന്നത്, we'll see this particular thing. So in bankers algorithm, the data structure for this bankers algorithm is very important. There are n number of process will be there and there will be n number of resources will be there. This data structure എന്തൊക്കെയാണ് ഉള്ളത് പറഞ്ഞാൽ here it will be working based on availability. So maximum, so availability പറഞ്ഞാൽ for example നമ്മൾ ഒരു ലാപ്ടോപ്പ് മേടിക്കുന്നുണ്ടെങ്കിൽ നമ്മളുടെ minimum configuration if you take 1 TB is the thing. So that is called as maximum. എൻ്റെ സിസ്റ്റത്തിൽ എത്രയാണ് maximum പറയുന്നത്, that is the thing. Availability for example അതിൽ 1 TB if I use 500 GB that is called as allocated. Availability പറയുന്നത് 500 GB യൂസ് ചെയ്താൽ 500 GB will be available. And needed പറയുന്നത് current ആയിട്ട് if you are getting any new request that will come under need. So this for us is very important. We have to know what is the availability, what is the maximum allocation, and what is allocated value, and what is the needed one. Based on this only the bankers algorithm is working. So we'll go for the step 2. First നമ്മൾ കണ്ടുപിടിക്കുന്നത് needed matrix ആണ്. Once we find out the needed matrix, we'll get into the safe state algorithm. So ഈ algorithm എന്താണ് I'll explain. Problem detail I have explained in the other video. So the first one is a safety algorithm. Safety algorithm പറഞ്ഞ എന്താണ്, we have to find out നമ്മൾ കൊടുത്തുള്ള പ്രോസസ് എല്ലാം സേഫ് ആയിട്ടുണ്ടോ അല്ലയോ നമ്മൾ നോക്കാം. സോ അതെങ്ങനെയാണ് ചെക്ക് ചെയ്യുക പറഞ്ഞാൽ initially we will be checking work and available both are same. വർക്കും അവൈലബിളും ഒന്നാണ്. So what we'll check initially നമ്മൾ ഓപ്പറേഷൻ കഴിഞ്ഞോ ഇല്ലയോ നോക്കും. So finish of I പറഞ്ഞ പ്രോസസ്സിൽ for example ഇതിൽ 1 2 3 4 n number of process ഉണ്ടാവും. So once it finish it will be come out. If it is not come it will be come on ആയിട്ട് വരും. So initial ആയിട്ട് നമ്മളെ നീഡും എത്രയാണ് available വർക്കോ will be check. If the need is less than availability, if condition is true, it will move to the step 3. If condition is false, it will move to the next process. So ഇവിടെ നമ്മൾ നോക്കാം need is less than or equal to work. So after that, if the condition is true, what will happen? Work is equal to work plus allocation. So we will be getting a new availability and we'll move to the next step. So this how the safety algorithm will work. Meanwhile, once safety algorithm, the second step is over, we'll move to the third step, that is called as resource request algorithm. Resource request algorithm, probably I'll show you the example of this particular problem. So if any banker's algorithm problem is asked, that it will consist of three parts. First, we need to find out the needed matrix. Second one, we need to find out the safe state sequence, and third step will be resource request algorithm. Adile third algorithm another, so we'll have a look on this. So in resource request algorithm, what initially they check, initially whatever the request they given, that will check with the needed one. If this condition is true, it will move to the next step. If this condition is false, we'll tell this can't given immediately. So we'll give a conclusion, this can't be given immediately. In the second case, so this condition is true if you take request is less than available. If this condition is true, it move to the next step. Then what will happen is an added the step, this condition is step 2 true, it will move to step 3. So in step 3, what it will happen, availability is equal to whatever the current available we are given, it will be minus with the request, allocation on the add down, need on the add down. So we'll see, I'll explain this detail in the problem section. So the algorithm from Noka. So this how you'll be getting exam in the question in the exams. So in this particular case, if you take to illustrate the use of banker's algorithm, consider the system consists of 5 processes. The 5 processes are P0, P2, P3, P4 and a process, and it consists of 3 resources A, B, C. So ഇതിൽ 3 resources ഉണ്ട്. So the total number of A, it consists of 10 instances, B consists of 5 instances, and C consists of 7 instances. Then we'll see how the problem happen. So ഇതിൽ 3 block ഉണ്ടാവും. One is allocation, maximum and available. So if you add up all these things, you'll get 7, 2, 5. If you subtract with the original value, we'll get 332. ഇതാണ് നമ്മൾ current. So first step in this, we need to find out needed matrix. Needed matrix എങ്ങനെയാണ് കണ്ടുപിടിക്കുക? It's nothing but maximum minus allocation. If you subtract, you will get a needed matrix. So for example, this particular case, if you take this example, if you take 753 minus allocation ombo, it will divide. So 7 minus 0 will be 7, 5 minus 1 will be 4, 3 minus 0 will be 3. അതേ മാതിരി ഇങ്ങനെ 3 minus 2 will, so ഇങ്ങനെ കണ്ടുപിടിക്കുന്നതാണ് needed matrix. So once you find out needed matrix, what we can do, we'll go for safe state sequence. Safe state sequence എങ്ങനെയാണ് കണ്ടുപിടിക്കുക പറഞ്ഞത് I have detailed explained in the problem, so that we will see. Thank you so much.